Hello and welcome back to my channel. In today's video, we are going to learn about one of the simplest algorithms in machine learning, that is k-nearest neighbor or KNN. So without further ado, let's get started. So what is k-nearest neighbor or KNN? KNN is a supervised machine learning algorithm used for classification and regression. It works by finding the k closest data points to new data point based on a distance metric like Euclidean distance. It then makes predictions based on majority vote for classification or average for regression. It is also called as a lazy learner because KNN does not build a model during training process, it just stores the data and makes prediction when it is required. Let's see an example of KNN. Suppose we have clusters of data like this. Here are two types of data, that are blue circles and orange diamonds, which are labeled as class 1 and class 2. Now, if we have a new data like this and we have to find out in which class it belongs to. For that, we have to find its nearest neighbor as shown in the figure. To calculate the nearest neighbor, we have different types of distance metrics, which I will discuss later on. So these are the nearest neighbors of our data. After that, we have to decide the value of the k. If it is 3 like this, then the majority will decide. Here, majority is 2, which are of class 1. Therefore, our data also belongs to class 1, that is blue circle. Hence, this is the basic concept of KNN. What is k in KNN? In KNN, k is the number of nearest neighbor the algorithm considers while making a prediction. Let's see an example. If we want to predict whether a new student plays basketball or tennis based on his or her height and weight, so if k equals to 1, we look at the closest student only. And if that student plays basketball, then it will predict basketball. But if k equals to 3, we look at the 3 closest student. If 2 students play basketball and 1 plays tennis, then the majority is basketball. Therefore, we predict basketball. Hence, the value of the k can be adjusted according to the type of our data, and choosing the right k is important. The small k is more sensitive to noise and can overfit, whereas the large k gives smoother decision, but it may lead to underfit. There are different distance metrics for different types of data. The most used formula in KNN is the Euclidean distance. Similarly, we have Manhattan distance, Minkowski distance. The most used formula in KNN is the Euclidean distance, and the choice of the distance metrics affect the KNN performance. The formula to calculate Euclidean distance is like this, and using this formula we calculate nearest neighbors. KNN algorithm. The first is the collection of data, and then choose the number of neighbors, that is k. The third is calculate the distance between new point and all existing data points. And the fourth is sort all the data points based on distance. And then choose the k nearest neighbors. Choose the majority class among neighbors if it is classification. If it is regression, take the average of neighbors value. So this is the KNN algorithm. Mathematical explanation. Now let's see KNN with some real example. Suppose we want to predict whether a person will buy ice cream or not based on temperature and humidity. Here is our data. One is temperature and the other parameter is humidity. And in buy ice cream column, if it is 1, then it is yes. That means he or she can buy ice cream. If it is 0, then it's no. Now we want to predict for the condition if temperature equals to 24 and humidity equals to 57. First, let's calculate Euclidean distances. For example, when the temperature is 40 and humidity is 70, we consider this as x2 and y2. And our x1 and y1 are 24 and 57. Then let's use the Euclidean distance formula and get the result as 20.65. In the same way, we calculate for all data and get like 13.60, 3.16 and 7.61. Now, if k equals to 3, then we choose the nearest distances as 3.16, 7.61 and 13.60. Here two values has no and one is for yes. That's why our prediction is also no, because majority vote goes for no. Therefore, a person cannot have ice cream on the condition where temperature is 24 and and humidity is 57. So this is how we can make prediction in KNN. Advantages. It is very simple and easy to implement. It is versatile as it works with classification and regression. There is no training required because it is called lazy learner. It works well with small datasets. Disadvantages. Cost of dimensionality, that means it doesn't work with high dimensional data. Choosing the value of k can be tricky. Slow with large datasets as it computes distance to all points. It can be prone to overfitting. Real-life applications of KNN. It can be used for recommendation system for suggesting products by history of other users' purchase. Another is customer segmentation. We can group customers and analyze their shopping behaviors. It can be used for medical diagnosis for identifying different diseases based on various health measurements. Another is KNN can be used for spam detection. If there is a new email, then it is compared with existing spam and non-spam emails. After that, it decides whether it is a spam email or not. So these are some of the applications of KNN. There are so many other use cases of KNN in real life. Okay, that's it for KNN. We learned that KNN depends on its neighbors. That is why choosing the value of the k is really important. It is great for smaller datasets. In the next video, I will come with its implementation in Python. If you found this video helpful, don't forget to like, share and subscribe this channel. See you in the next episode.